Once again, we're coming to you from the City Square downtown, a very busy intersection, and today's topic is inferential statistics. Let's begin. It's presentation 8.4, and we want to acknowledge the development team of Brad, Spencer, and Amanda, and finally the material may be found in your workbook on these pages. Now we're going to look at this illustration here. We have a dispensing machine at the entrance of the college dispensing fluid in the amounts of 160 grams of coffee, and the students feel they're getting shortchanged, that it's not performing and delivering liquid in this amounts. We take a sample of 22 cups rather, and we're going to do a two-tailed test. We find the data on the right here. Here's the sample mean, x-bar, and sample standard deviation. Now part A consists of the null hypotheses. If we say that there's no change, that the mean is still 160, which allows us to place the normal curve at 160, the alternative is it's different from 160, mu spec is not equal to 160. At a 5% level of alpha, we're going to carry out this test. Sampling distribution follows a normal curve. The mean is about 160, and standard deviation, standard error, is given by 0.501, called the standard error. And the critical values, we're going to a two-tailed t-test. So we're looking at two tails here, 5%, that's 2.5% each. We're going to reject H0 outside these two red lines, and inside we're going to fail to reject or accept H0 as true. Now here's the t-table. We look at 21 degrees of freedom and go over to a column where the one tail is 0.25, and this becomes our critical value, and they appear on the screen here. So the test criteria becomes reject H0 if your t is less than minus 2.096 or greater than plus. You fail to reject it if it's between those two values. Now part D is the test statistic, x-bar, mu, standard error. These are the numbers corresponding to those entities. The t-statistic is minus 1.138, which falls just to the left of center, and we're saying that falls between these two red lines, and the conclusion, we fail to reject H0. There's insufficient evidence to reject H0. Now we're going to look at part E, the p-value. The p-value is the probability of getting an x-bar more extreme than what we just observed, or an x or z or t more extreme than the t-statistic, or 1.138. And look on the screen here. 1.138 occurs somewhere near the center here. The p-value is the area under the curve in those blue arrows. Going to the table, 21 degrees of freedom, we're trying to find here 1.138. As you go across here, you'll see it's just to the right here. And going up here, this would be the one tail value. Now it's not in the table, but we can find it. It's actually 0.134. And because of a two-tail region, we double that for 26.8% chance of observing an x-bar more extreme than what we've just observed, or a z more extreme than 1.138 when H0 is true. This is not an unreasonable result. This is the end of presentation 8.4. Please review once again and go to presentation 8.5.